So after you've picked up some basics for logarithms, okay, let us very quickly again go through some of the summary of the meaning of logs. So referring to this basic equation of log, okay, here's my interpretation. So log base A of B equals to C. I would say the base would be a starting point. I would like to go from A to B. So if I treat B as the ending point, okay, I need something that brings A to B, right? And C would be the means that take us from A to B. So C is actually the index, the power to go from A going to B, okay? And C is the result after the log. So I would say, what is log? After logging, you would get the power to bring you from the base to the result, okay? So C is the index actually. And if you're able to write from here interchangeably with this, or you go from here and rewrite it as this, so you must know how to go from here to here, or from here back to here. Now for the case when the base is the number e, there is a special name for this log base e, and that's what we call the ln of b. Okay, so how do you interpret this? This is basically asking that e to the power of what equals to b. Okay, so that is very important. That is actually the meaning of ln. E to what power equals to b. Okay, and so that equals to c. So before we start any problems, okay, we have to understand that while e itself is a number, okay, 2 point something something, okay, but ln itself is not, okay. Ln is like an operation, okay. Operation meaning you do something to a number, okay. Ln is like an operation. So ln, this symbol itself, has no meaning, all right, until it is followed by a number. For example, ln e, it has meaning, okay. It means e to the power of what equals to e. Oh, and that answer is 1. And for this one, ln1 means e to the power of what equals to 1, and that answer is 0. Okay, and then because it's an operation, there are many laws that it follows. Okay, so we could use some of these on the problems. So for example, for this complicated expression, without using calculator, okay, we need to simplify some of these expressions, and then we can cancel some of them. Now, to do these kind of questions, okay, the key is you need to be able to identify the basic units. What I mean by basic units, for example, ln2 or ln3, because these are prime factors, ln of prime factors. So maybe if we could break these up in terms of ln2 and ln3, then we could combine them or simplify them. Now, for the numerator, if you look at this one, okay, I've broken down ln of a over b into ln a minus ln b, and this is using this law right here. Okay, this one's very important. And for this part, ln 81, okay, because I've identified this as one of the basic units, and I know that 81 is a power of 3, so then I will rewrite it into like this. Next is we can refer to this law here. Okay, ln of m to the power of n, I could actually move the power to the front like that. Okay, so I could just move the 3 to the front, 2, and the 4 right like that. So now when it becomes obvious that you have 3 times this basic unit minus 2 times this basic unit, etc., you know this and this can be cancelled, right? And now I have 4 of ln3 plus 1 of ln3. Then I could combine it as well. So the ln2s are disappeared, and that leaves us with this. That could be cancelled like that. And this gives us the answer of 3 over 5. I'd like to bring your attention to this law right here. Okay, so ln 6 equals to ln2 plus ln3. Fair enough, but a lot of you always get mixed it up with ln2 times ln3 equals to ln6, and that is obviously wrong. It's also wrong to say that ln2 times ln3 equals to ln5. Okay, so you can say that the product of two ln's are not bringing us to anywhere. Okay, but the sum of two ln's is the ln of the product of the numbers.